Okay, for this flex day learning, what you're going to be doing is you're going to be making a track so that it matches a position time, a velocity time, and an acceleration time graph that's given. So what you're going to do is you're going to open up your email that's sent to you, and you're going to click on this link in this Excel document, and it's going to take you to this program. You can do a tutorial, you can do a practice, or whatever, but the challenge problems is where you're going to be doing the work. And what I'm going to actually do, I'm going to do some problems I've made up already. I'm going to show you how it kind of works. So what I have to do is I have to construct this ramp such that it will produce this motion in this ball when I roll it. So if I hit roll right now, you'll see it doesn't match that dotted line at all. So you could do this trial and error, but you're going to do quite a few and it's going to take forever. Or there's a better way. So notice it starts here at 250 centimeters. So I can adjust this so that it's actually starting where it's supposed to. I can also look at the velocity time graph and figure out where it's starting at, and you can see that it has a negative velocity. That means it's moving to the left, and I'm guessing that's about negative 20 if that's negative 50. So I'm going to slide this slider over here to negative 20. Okay, so I can roll it again, see if I'm getting closer. Oh, I'm closer for a little while, but then it kind of goes haywire again. So getting better, not quite there yet though. So how can I do this even better? Well, I've got the position and I've got the velocity set up, but you'll notice that right here the velocity changes. In fact, it speeds up. So it's rolling in the negative direction for a while, and then it's actually going to be speeding up at a nice constant velocity, and then it speeds up somewhere. Now, where exactly is that? Well, this time axis tells us it's about 2.5 seconds. So if I go back to the position time graph, at about 2.5 seconds, that's about at 200 centimeters. So it's going to continue on nice and flat here all the way to 200, and that's where it's going to start speeding up. So in other words, this is going to be dropped down. Now how far do I drop it down though? Well, in order to figure out how far to drop it down, I look at the acceleration time graph, and I can see that it's about at negative 20. So that's about 2 drops. So you'll notice if I just do 1 and hit roll, you'll notice it's not quite enough. So that didn't quite work out. So I'm going to go back to the acceleration time graph here, and I need to make it so it has a slope of 2 because that's at negative 20. So for every 10, that's one. That's a difference in elevation of 1. So if it's 20, then it needs to be an elevation of 2. And so I'm going to put it at 0. And you'll notice that it has that same acceleration almost all the way to 5 seconds. And 5 seconds occurs at about 100. So good, I've got that slope all the way to 100. That's nice. Then going back to the velocity time graph, you'll notice that, yeah, just about at 5 seconds, it starts slowing down again. So here it's going to go at a constant speed for a little while, then it speeds up in the negative direction, then it starts to slow down in the negative direction, actually coming to a rest. Well, I need to know what that acceleration is. And that acceleration looks like it's about, well, I'm guessing it's about 30 centimeters per second squared. That means an elevation of 3. Well, I've got it right now at elevation of 10, so I'm going to change this to elevation of 3. So that'll take me all the way to it stops, and then it'll start rolling back the other way, and then you'll notice it kind of repeats that behavior right here. And this looks like it's nice constant velocity then on out, so I'm going to drop this down to 2. And let's see how it works now when I roll a ball. And sure enough, it matches. And as soon as it matches, then I would just simply record all these. Notice this is at 3, this is 0, 2, 2, 2, 2. And I'd also record the initial position and the initial velocity. Okay, so let me go to the tutorial so you can see how this works. I'm going to try one more. So this is at 50. So I've got to put this at 50, which it is, and the initial velocity is, it looks like it's about, I'm guessing it's negative 20 or so. So I'll put this on negative 20. And so that means it's heading backwards to the left, but it has to be slowing down. Let's figure out what the acceleration is. Looks like the acceleration is 20 centimeters per second squared. That means this has got to be higher than the 5 here by 2. So I'm going to raise it up to 7. And notice it keeps that acceleration all the way to about 6 seconds. So at about 6 seconds, where is it at? 6 seconds is about 200. So it has to have that slope all the way to 200. It has to come down one more. So notice that's a nice constant slope all the way to 200. And then it has a constant velocity from then on out. That means all of these have to be down at the same height. And now I'm going to roll the ball. Oh, see, my acceleration must be different, and I missed the acceleration by 1. So, or maybe I missed my velocity by 1. Let me roll it again. Yeah, I missed my velocity by 1, so the velocity must be negative 30. Let's try negative 30. There we go. And now it matches. So what do I do then with the spreadsheet? Well, on the spreadsheet, then I'm going to record all my information. Like this is the tutorial I just did. So I put in here my height. This is 7. The next one was 5. The next one's 3. The next one's 3, 3, and then 3. And my initial position was 50. And my initial velocity was negative 30. And I think that was like my 4th or 5th roll, something like that. Alright, so then I would need to do all the exercises. There's challenge problems, challenge number 1, number 2, and so on. I need to expand this so you can see it. Zoom in a little bit. So challenge number 1, challenge number 2, 3, 4, all the way up to 15. And once I have all that recorded and I've done them all for my FlexDay Learning, then I would save it to my desktop and then email it back to me. So to Mr. Limfesti. And that's it. That's all you'd have to do.